Project 2.9 Unpacked, the 595 Shift Register. The goal of this project is to create a circuit with the same function as the 595 Shift Register through the use of only hardware. The main components within this circuit are two SN74HC74N chips, one CD4081 AND gate chip, and a set of buttons and switches. Let's start with the SN74HC74N chip and how D flip-flops work. This chip is a dual D-type positive edge triggered flip-flop IC with preset and clear functionality. Each of its two flip-flops include a data input, clock input, clear and preset inputs, both active low, a Q output, and a Q inverted output, along with power and ground pins. A D flip-flop works by capturing value at the D input at the exact moment the clock signal transitions from low to high, the rising edge. At that point, the value at D is latched and held at the Q output, even if D changes afterward, while Q inverted becomes the opposite. This behavior makes D flip-flops ideal for storing binary data and controlling timing in digital circuits, since they only update on clock edges. Now, let's talk about the 4081 chip. This chip is a CMOS logic IC that contains 4 independent 2-input AND gates in a single 14-pin package. Each gate has 2 inputs, A and B, and 1 output, Y, and it performs the basic AND logic function. The output is high only when both inputs are high, otherwise the output is low. Internally, the chip uses CMOS transistors for low power consumption and wide operating voltage, typically 3 volts to 15 volts. The pinout includes voltage and ground, while the remaining pins are used for the inputs and outputs of the 4 gates. The 4081 is commonly used in digital logic circuits for combining signals, enforcing conditions, or building more complex logic functions. For the input buttons, I use pull-up resistors to make sure the logic levels are clear and stable. When a button isn't being pressed, the resistor pulls the input pin up to 5 volts, a high state. When you press the button, it connects the pin to ground, low, which the circuit uses as a signal. This setup avoids floating pins and glitchy behavior. This circuit emulates the basic functionality of a 74HC595 shift register by mimicking how data is serially shifted in and then displayed in parallel. Like the 595, which uses a series of D flip-flops to shift in bits one at a time with each clock pulse, this circuit uses the SN74HC74 D-type flip-flops connected in series. Data is entered 1 bit at a time using a manual input and is shifted through the flip-flops using a clock button, just like the 595's shift register responds to a shift clock. The use of AND gates to control when the outputs are shown is similar to the 595's latch mechanism, which controls when the shifted out data is transferred to the output pins. Finally, the bar graph of LEDs acts like the output register of the 595, providing a real-time visual representation of the 4-bit values stored in the register. This hands-on version helps illustrate how serial to parallel conversion and output control are handled in the actual 74HC595 chip. So here's how this circuit in action. First, I press the data button to set a high or low bit. Then I press the clock button, and that value gets stored in the first D flip-flop. Each additional clock pulse shifts the data 1 position down in the chain, passing it from one flip-flop to the next. The Q outputs of the flip-flops are connected to a 4081 chip, which contains 4 2-input AND gates. These gates take each Q output and combine it with a control signal from a toggle switch, acting as an output enable line. If the switch is on, logic is high, and gates pass the stored value through the LEDs arranged in the bar graph. If the switch is off, logic low, the gates block the signal and the LEDs stay off. This makes it easy to visualize the bits as they move through the circuit and gives you control over when the stored data is displayed, just like the output enable function on a real shift register. Overall, this project helped me better understand how shift registers and memory elements work, and how you can control data flow and output using logic gates and clock signals.